Today we are going to talk about gels and magmas. Gels are semi-solid substances in which the movement of the dispersion medium is restricted by the interlacing 3D network of molecules or macromolecules of the dispersed phase. Now, what is dispersion medium and what is dispersed phase? If this is the colloidal solution, basically gels and magmas both had colloidal dispersions. So if this is a colloidal dispersion, this is supposed to be dispersed phase, while the rest, the solvent, is supposed to be dispersion medium. Okay, now the dispersed phase is the movement of the dispersion medium is restricted by the dispersed phase. Generally, you can relate to this that the amount of the dispersed phase is more than the amount of the dispersed medium. And it can also be, it has another definition, semi-solid. These are semi-solid substances in which the large organic molecules or small inorganic molecules are interpreted or interpenetrated or enclosed by a liquid. What are organic molecules? Organic molecules are substances containing carbon and hydrogen, such as such as carbs, proteins, fats. These are organic molecules, and these are very large molecules. And the small inorganic molecules, these are such as potassium, sodium. These are small inorganic molecules. Moving on, these have certain characteristics, general characteristics. So one of them is that they are semi-solid or semi-rigid. Okay, the viscosity of the gel is caused by interlacing and internal friction between the particles, which is responsible for semi-solid state. Now, these are highly viscous substances, highly viscous. Have you seen, we might have seen aerogel or even the gels that you put on your hairs for styling. These are very viscous substances, and they are semi-solid substances. This is because of the internal friction between the particles. As I told you earlier, that the amount of the dispersed phase is more than the amount of the dispersion medium, so there's a high friction between the particles. Okay, high friction between the particles, which results in their high viscosity. There are strong forces. Sometimes there are strong van der Waals for interactions between the long, twisted, and matted strands to form amorphous and crystalline regions. So, for example, Tragacanth. Tragacanth Asians might call it as Imli. Okay, it means that there are long strands. I'm gonna take Tragacanth as an example. In Tragacanth, there are long strands of substances which have van der Waals interactions. Now, those familiar with the chemistry might know that these van der Waals forces are very strong interactions between the molecules, which are very hard to break. Now, the appearance, sometimes they might appear as clear as H2O, that means as clear as water, and sometimes turbid because ingredients might not be completely dispersed. Turbid is it means that it's not clear. It might be milky, it's cloudy. You can say it's cloudy most. So that's because colloidal solutions, they are not miscible. Since they're not miscible, so they do not have a very clear or transparent appearance. They are mostly turbid. Okay. Now, there are two phase systems of gels for our single phase systems of gels. In single phase gels, macromolecules are distributed so that there are no distinct boundaries between the molecules. For example, over here. Now, there are no distinct boundaries between the macromolecules. You cannot define a boundary of the molecules over in the single phase gels. However, in the two-phase system, or also known as magmas, when gel's mass consists of flocules or small distinct particles, they are called magma or milk. Now, these are the aggregation of molecules. Aggregation of molecules. there are distinct boundaries, and they are called two-phase system. Now the major difference is that there are in single phase systems there are no distinct boundaries, and in gels there are distinct boundaries.